This tutorial is intended to be used for uh, the repetition of tutorial 8, which was generating a helix using the mathematical expression which give the helix in space. But in tutorial 11, what I would like to do is repeat that same problem, except that the mathematical expressions are not used directly, and in order to do that, I broke it down to these two intermediate steps. One is the present tutorial, which is number 9, and I will be generating 3 cycles of a cosine curve. And once I do that, then I go in the tutorial 10, I use that result from the present tutorial in order to generate 3 cycles on the sine curve. All right, so here's the situation. Uh, what I'm planning to do is to take 11 points which have the height of a cosine curve, okay? Basically, it's cosine of 2 pi t, the height of the cosine curve, and then input these 10, 11 points, and then put a spline through it, and then based on that spline, I repeat a sufficient number of times so that I get the 3 cycles, okay? So we're not going to be using this directly. Of course, I need the heights I need this expression in order to find the heights, but we will not be using it directly to generate the cosine curve, okay? And as I said, the reason I do this is in tutorial number 11, what I would like to do is generate this helix, and this helix, the x-coordinate of it comes from what I just showed you. The y-coordinate of it comes from in tutorial 10, which is going to be massaging this cosine curve so that I get the sine curve. And finally, the z coordinate is just a straight line with a slope of 1. Now, we'll worry about that thing later on. Okay? These are the 11 points that I'm taking from the cosine curve, so only the heights are needed, and the heights and of course the horizontal uh, horizontal coordinate are needed. Okay, so let's go ahead to 3D experience, and for a reason that's convenient for me, I'm going to create a plane which is 4 inches away from the global XYZ. This is not necessary, but I feel more comfortable working on a plane and not on this global XYZ planes, which is going to be well, used later on. All right, so let's go ahead and create a plane 4 inches away from, for example, is that the YZ plane? Your YZ plane? Okay, good. On that plane, I will sketch. And what I like to do is to create these uh, 11 points. Okay, and here's how I'm going to do that. There are different ways of making points, but the one that I'm going to make by inputting coordinates, see, points using coordinate, just type them in. So these coordinates from that table are 0 and 1. Okay, next one. It is 0.067, 0.067, and 0.914, 0.194, sorry, 0.914, 914, okay. Let me double click on this, maybe it'll keep it open, yeah. Now the next one is 0.125. Note that these points are being created. 0.125, it's kind of hard to see on the screen, but believe me, it is created. Yeah. Let's see now, 0.125 and 0.707. Let's check it actually. I'm going to check something here because this first one doesn't look right. Let's check it out. Let's see now, how many points have we done so far? Okay, 0.1 was supposed to be 0 and 1. That is correct. 0.2 was supposed to be 0.067. Oh, there it is. That's why it didn't look right. So 0.914. Okay. 0.3. 0.125, 0.707. Doesn't look right either. Let me delete this. 0.4. Okay, so let's go ahead and fix this thing. This is let me see now. This is going to be point 0.125, 0.125, and 0.707. Yep, that's better. Let me double click on this thing so it keeps it open. Next point is 0.167, and the Y is 0.5. Okay. Next one is 0.2, and the Y is 0.309. I'm sure there are more efficient ways of inputting these into Catia, for example, read it in an Excel sheet or something like that, but that's okay. We don't want to do that. 0.25 and 0. That's already 0. Okay, very good. Next one is 0.3 and negative 0.309. Negative 0.309. Yep. And then 0.33 and negative 0.5. 0.5. And then 0.375. 0.375 and negative 0.707. 0.707. And then it's 0.433 and negative 0.914, and the final point is 0.5 and minus 1. Minus 1. Okay, so here's the situation. These are the points that you see I generated, and these points represent this table. Okay, and there are actually 11 points, but it assumes that there may be 12 here, but that's because it started, there was no 3. Remember, I deleted 3. Okay, good. Next thing I'm going to do is I will reflect these. I will reflect these with respect to a vertical line here, because notice that the cosine curve goes, these are the points that I generated. I want to get this piece of it, so I'm going to reflect it. And one way of doing it is create a line going from here to here, the vertical line, okay? And then select all of these points. Let me see now, select all of these points. Maybe I select it with a, yep, and then mirror it. The mirror with respect to that. There we are. Okay, I don't need this line. I'm going to delete this. I'm going to delete this. By the way, 11 and 10, 21 points. So there should be 20. Let me see now. How many did I have here? I had 11 points here and 10 points over there. Okay, 10 points over there. And yeah. So I did delete this line. I'm going to delete that line. Okay, good. Let's see how many points we have now. So now there should be 21 points. Believe me, it is 21 because that's 11. That's that's 11, and then 1, 2, 3, 4. Let's see now. Okay, so this is 11. Up to this point is 11, and then from 12 downward, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 points. Okay, good. Now, what I want to do is I'm going to put a spline through these. So let's go ahead and do that. Here's a spline. Let's zoom in so that we can. I could have done uh, this left side and then reflected it also, but I'd rather do it like this. So I'm going to select all of these one by one. It was probably better if I put the spline on half of it and then reflect it, mirror it. That's okay. Where is it? Okay. I'm hoping that they all I picked it through the point. It was better if I did it through the tree. There was less possibility of error. Now, okay, now that we have generated one cycle of this cosine curve, we would like to create two more. And perhaps the easiest way, there may be other ways, the easiest way is to select this spline and then go down here, look under translate, okay? Put the cursor, we want two replication, two instances. You put the cursor there and you say, look at the bottom left corner, see what it says, start or click the translation point. So let me put as translation point, start point 0, 1, enter. Read the bottom, it says look or click on the translation endpoint. So let's make this thing 0, 2. See what happened? Oh, wrong way. What was that? So what you do is you click on the translation. See that? Look in here under translation. Read this thing carefully. It says at the bottom left corner of the screen, it says select or click the translation start point. Well, let's put down 2, and for the V, I put down 1. There we are. Anyway, you can play with this thing a little bit. Basically, I did this thing. It asks you for the start point and the end point, and I did it. If you zoom in, better not be any gaps in here. No, that's good. That's good. So exit. There we are. So what you see there is actually this curve. Okay, and so notice that if you go back to that sketch, the x coordinate of this point, or the horizontal coordinate, must be 0. If you must be, sorry, 3. The y coordinate should be 1. If you double click on this, yeah, 3 and 1 cancel. Good. So what I have done here is for you to generate by 11 points. First I reflected, get the full cycle, one cycle, and then selected that, and then use the translation, translated it 2 instances, and that translation toolbar or dialog box, because you have to select the start point and the end point, may require you to do a few trial and errors and get it to work. Okay, folks? So that takes care of uh, this portion. So in the next tutorial, which is going to be video tutorial uh, number 10, I will take this data that I just generated, and out of that, we'll get 3 cycles of a sine curve. All right. Good luck.